Hello, everyone, and thank you for joining us. My name is Andreea Munteanu. I'm AML Product Manager at Canonical, and I'm not alone. Together with me, I have Kimonas. Kimonas, I will not try to pronounce your last name, and even if we've been working for a long time together.
Those Greek names. It's Sotirchos. Hey, folks.
Thank you for joining me as well, Kimonas. And we'll talk about how to build your machine learning pipelines with Kubeflow. And the exciting part of this webinar is that Kimonas has a demo prepared for us on how to build a pipeline, how does pipelines look like in Kubeflow. So I will not make it any longer, but before we get into the demo itself, let's talk a bit about machine learning pipelines. Well, they're an important component of the machine learning ecosystem, ensuring simplified experimentation and capability to take models to production. They're actually a series of steps to automate how ML models are created in order to streamline the workflow. They can be, as we see in the picture from the slide, a series that includes the entire machine learning lifecycle, but often they're just a part of it. So you can build pipelines for different purposes of your workflow as well. Well, usually in order to build machine learning pipelines, you need an MLOps platform or machine learning operations platform. What is MLOps, you might wonder. And for those who are new here, I'm just going to define simply MLOps as DevOps for machine learning. It's a quite a new practice, maybe not that new anymore, that enables data scientists and machine learning engineers to automate their workloads and to work in a reproducible manner. Now, how do you use MLOps platform, or what kind of MLOps platforms are there on the market? I'll start by introducing Charm Kubeflow. Actually, I'll start by introducing Kubeflow, the upstream project. And Kubeflow has been pioneering in the MLOps ecosystem, being one of the very first MLOps platform. Nowadays, it's part of KubeCon North America. You see, that's not correct. Kubeflow is part of CNCF as an incubating project. I was thinking of KubeCon North America because I just saw part of the community. But going back to Kubeflow itself, it is designed to automate machine learning workloads, and it runs on Kubernetes. It is a suite of leading open source tools that developers can use to build models, optimize models, and last but not least, train models themselves. That's why you have their Kubeflow notebooks for training the models, very similar to Jupyter Notebook. You have Kubeflow pipelines for automating the workloads, and we'll go more in details into this. Then you have Katib for model optimization, and then last but not least, you have these days Kser for model deployment as well. It's a portable platform. It runs on different distributions of Kubernetes, and if you like to get to know more about the project, or if you'd like to contribute to the community, don't shy away from going on kubeflow.org to learn everything you need about the platform and itself. Now, what is Charm Kubeflow? Charm Kubeflow, or CKF, how we often call it in a short manner, it's in one of the official distributions of the project. It is Canonical's distribution of the project as well. We've been involved in the community for at least the last 5 years, and we provide the same capabilities as the upstream project does, but in addition to that, we provide security maintenance of the packages underneath, as well as further tooling integration. Whether I think of MLflow or Feast, CKF and our mission with CKF is to enable the whole ecosystem to be seamlessly integrated, such as data scientists spend less time on tooling and more time on building models. Also, it is an enterprise-grade solution, so having observability capabilities came natural to us. That's why you can always use CKF together with Canonical's observability stack, which contains Grafana, Prometheus, Loki, in order to ensure the observability of your AI infrastructure. And then talking about enterprises, we provide support or managed services for those who are ready to go with a commercial solution, even if the solution is similar to the project you feel is fully open source. And then also we are always at the edge of innovation, whether we talk about enabling the platform on confidential computing VMs, or we integrate with optimized tooling from different silicon vendors. We always strive to innovate and to give our users the best distribution. Now, what are Kubeflow pipelines? Because this is the main reason that we came here. I like defining Kubeflow pipelines or KFP as the heart of Kubeflow. It is the component that enables the creation of machine learning pipelines, and it's basically used to help and build container-based ML workflows that are portable and scalable. The main goals of pipelines or Kubeflow pipelines are to simplify the orchestration of the end-to-end machine learning pipelines, but also enable data scientists to experiment with various ideas and techniques in a very simple manner. And then last but not least, to build components that can be reused by different users so they can quickly put together their solutions, enabling collaboration as well as reproducibility. Now, if I look at the architecture of Kubeflow pipelines, I will not bore you too much because this is really designed to be a hands-on workshop. It is quite easy to see that they seem like a complex component with capabilities that unblocks users to automate their workflows and reduce actually the time spent on their manual tasks, because that is the main reason why I think organizations and also data scientists do machine learning. Now, if you look at this architecture, some of the tools, such as the ML metadata service or the artifact storage, can also be replaced depending on the expertise that developers have, or also on the infrastructure that they have in-house. Now, the diagram itself also shows you that you can interact with KFPs through the UI that Kubeflow has, but also through notebooks themselves. I'm not sure, Kimonas, are we going to share this in the demo?
Let's see how much time we have. We can also have some fun with the notebooks as well.
Okay. Now, in that case, I will hand it actually to you in terms of what are we going to do with Kubeflow pipelines. Are you ready to show us?
Thank you, Andrea. Actually, I'm quite excited because to ensure that all of us are in sync with what we're going to see, the main goal of this, of what I'm going to demo with you, is that, at least for me, when I was initially looking into pipelines, one of my biggest problems was being able to grasp, if I have my code deployed for actually even training a model, how can I what is the journey all the way to then for me to be onboarded to Kubeflow pipelines? So the goal of this demo on how we're actually going to do it from scratch together is start from an initial very simple code, because my goal is not to show you how to create the best model there is, but what are the patterns that you will need to do once you have your code for training an initial model, how then start converting into a pipeline ecosystem so that then you can get even more complicated graphs and have it trained with different hyperparameters, etc. So the goal is for you to try to see my own suffering of how I would try to go to actually take the initial code and convert to a pipeline. So the goal by the end of the demo would be for you to know, once you have your code, what are potential pitfalls that you might see, what are the best way to structure your code, and how can you get to develop even locally and have a good journey for going from your code all the way to pipelines that can run on a Kubeflow cluster that you can easily iterate on and develop. So
Thank you, Kimonas. Let me share the screen so we can all see your suffering. I'm curious now.
So we're actually going to do something very, very simple. I have a very simple Python code, which I'm going to show you in a second, and the requirements that are quite straightforward. We have Docker, which we'll see in a second why. KFP, because we're going to be using it later on to create our pipelines, and then the regular pandas and scikit-learn. Now, again, the goal of this tutorial is to actually go super simple. So I'm not going to show you a very advanced. Actually, it's one of the simplest cases with super bad performance, but please don't quote me on the performance of the model. So actually, on a high level, it's a very simple flow in which we're going to get our data set from a query parameter. For now, it's a simple one for wine quality that we're hosting on GitHub. So we're going to have our URL. We're going to have one function that needs to download the step and creates the pandas data frame. Then we will have a pre-process function that takes this data frame and pre-processes it. And then we're ready for the training, for which we're going to define a couple of hyperparameters and then run our train function that takes as an input the initial data set and the hyperparameters, and will produce a model. I didn't want to go too deep and overcomplicate the steps, because what I really wanted to keep from this is the high-level overview of how can I go from 1,000 feet above and convert my code to actually a pipeline. So that's why this is explicitly kept super simple, so that the download step, as you can see, is we're just using requests, which we have also imported the package to just go and fetch the data. It's a raw GitHub URL. And with the help from pandas, we're actually going to read the response from the HTTP request and convert it to a CSV and to a data frame, and we're going to pass the data frame. And then the preprocess function is a super simple one, in which we're only replacing the spaces in the titles with underscores to ensure we can properly parse the data set. And lastly, the training of the model, all it's doing is just split the training and testing data sets, create a very simple ElasticNet classifier, and running it with a specific set of hyperparameters, training it and feeding it into our data, and then last but not least, checking its accuracy and returning the classifier. Again, a super simple model and flow, but we're going to see that there are actually a lot of nuances for being able to go to an actual pipeline, even when we start from a simple code like this. So let's get started then. And I'm going to create a wine-kfp.py file, and that's where all of the fun is going to start. Now, my proposal, this is actually the journey of how we're going to write. Everyone would expect, or I would suggest, to write a pipeline. And the thing that a lot of people don't know initially is that the best recommended way to start writing your pipeline is actually you can do it from your local machine. You don't need any Kubeflow cluster. You can write your Python code directly. And the reason we can do it is because KFP, but first we need to start with some simple imports. From KFP, we're going to import local, and we're going to see what it does in the model in a sec, and DSL. DSL is the data-specific language of KFP. And what we can do now, what KFP allows us to do is actually, in order to help us develop things locally, we can write the whole language of pipelines, or defining pipelines and running them locally, but via Docker images. So all of the mechanisms for doing data passing and the feature, actually most of them, there's a disclaimer, but you can also find documentation of some more advanced things of the pipelines that don't work. But this is for sure an easy way for everyone to iterate and start learning the pipelines. And how this looks like, and all we need to do is just go with initializing our local session with local.docker runner. And that's actually all it takes right now. So just by doing this, the KFP SDK will know that, okay, now for all the steps we're going to define in our pipeline, I'm actually going to run them as inside of Docker containers, so we can test everything we want locally. And that's a really the good benefit of this flow, that we're going to actually develop like 90% of our whole flow fully locally, and then we're just going to grab the output, put it on Kubeflow that runs in the cloud, and the same thing we're running locally, we're magically going to see it running on containers on top of pods in Kubernetes. So let's start with some boilerplate of name equals main to ensure we can run this when we execute our Python script. So that's going to be our main logic. And let's start now with taking one by one the steps that we had from the previous example, and try to convert them now into how they would look like as a pipeline. So the very first thing we have is our download dataset function, which we're just going to put over here. Now, the big distinction with KFP, though, is in order to tell pipelines that, hey, we have something, this needs to be a step, what we need to do here is actually add a decorator and tell to KFP that this is a component. And as I mentioned at the beginning with Docker, the main thing with Kubeflow pipelines is the fact that everything runs as a container. So when we define our component, the very first thing that we're actually going to do is use a base image, which is the initial image that Kubeflow pipeline is going to use to then put all of our Python code inside to run, and the dependencies, etc. So I'm going to do something very simple, because we've run this Python code with Python 3.12, we're just going to use the same version over here to ensure we have parity. So let's start with this. And as you can see, we're getting some complaints here and there about some packages that are not yet defined, pandas and requests for initially. So let's actually go and import them. So I'm gonna do import requests, and I'm gonna import pandas as PD. So here we are, and let's actually also start to create the definition of our pipeline to run it. I'm gonna do DSL's pipeline. That's the second most decorator we're going to use, and we're going to define MLOps pipeline, a function that now is going to create our pipeline so we can run it. So since we know we will need the URL, let's also go and have a dataset URL input parameter, and that should be all that we need. Now, the thing with pipelines is that we're having different functions, and at the end of the day, a function is composed from different components. So now we're going to use our function download dataset, which is actually decorated to be a component, and create an actual task out of this. So we're going to create a download dataset task, which is actually download. It's just the dataset that we have, for which we're going to pass it the dataset URL. So we're just going to create one simple step, one simple task that will go and pull the model for us. So as part of the name, what we're actually going to do here is let's import actually OS. And from the environment, we're going to get the dataset URL. So it's an environment variable. I'm keeping it super simple right now. So our URL is the dataset URL from the environment variable, and we're just going to call our MLOps pipeline. And for the dataset URL, we're just going to use our URL. It's going to be our URL. So with this, we should be able to just, let me source my Python environment as well. We should be able to now go and execute our one KFP pipeline even locally. So let's give it a go. I messed something up. Let me take a look.
You can even see a live debugging, which is
cool. Yes, that's the whole point. Everyone's gonna really see me suffer. So it's actually the data frame to dict is missing one parameter from the annotations. Let me see what is going on here. So we're trying to run our step for download dataset. Using pipeline, our component looks neat. We have our base image. What are we missing in this case? Oh, I think I'm missing the IO as well. For line 20. Let's try. Let's give it a try. Oh no, it's a different error this time. It's the same error, but in a different way. It's from our decorator and our component. Let me try to do this in case it's, oh no. What is going on? Pipeline component. So scrap this to make sure we're simplifying it as much as possible. There we go. So the type definition this time was incorrect. So lesson number 1, the return type is going to be important. Actually, that spoils things a bit, but we're going to see now why this is the case. But let's start with the error one by one. After we managed to create our component, the very first thing the pipeline complained is that hey, I always need to know positional arguments. And this is something that everyone we should need to be very early on aware that in Kubeflow pipelines, whenever we're trying to run a task, pipelines, the compiler that they have needs to always in the functions not have positional arguments, but always have named arguments. So in this case, we need to explicitly say, hey, the URL parameter should get this value. So let's also export the data set to have our URL, and let's try to run it one more time to see what will go on this time. So success. We're actually seeing it to start running, and the very first thing we'd expect is it tries now to create a container from the Python step that we defined. So Python 3.12 that we described, it's there. And immediately we can see a description of, hey, the URL parameter is over here. And we're actually greeted with our very first error, which is when we're doing requests, we're trying to get requests, we're actually seeing there that request model is not defined. And this is the very first entry for us to actually understanding how Kubeflow pipelines are working. And as you can see, requests are clearly imported, and I'm also not seeing anything in my editor. So why is this going on? Now, as we mentioned in the beginning, every pipeline step actually is running as a container. So the fact what Kubeflow pipelines will do is it's going to take this function and execute it as part of the container that starts with a Python 3.12 base image. So because of this, even though in my code I'm clearly importing the requests, the actual code that will run inside of the container does not. So thankfully, the Kubeflow pipelines DSL gives us a neat abstraction, which is called packages to install, which, as you can guess, is a list of packages that we want to have included in our container that will start by Python 3.12, in where KFP will take care of them pulling the packages. Of course, there are some asterisks of what do I do if I'm in a proxy environment or in an air-gap environment, in which in one case you would need to have some environment variables to tell to the final pod or container where to go and use the proxy. And in the other case, we'd have to use a different base and target image, although even directly, so that we can have all the packages pre-installed. So with this, let's actually take a look in our requirements.txt and take a copy of the pandas that we need. Dun, dun, dun. So the packages we need to install are going to be pandas. So now I'm going to start removing the things so that we can actually not do any of the imports and see them fail initially and early on from the code. Give me a sec. So what we're going to do now is immediately we see that both requests and pandas are complaining. We've defined requests and pandas, sorry. And for requests, we'll actually need to go and pull this one as well. So let me actually go and directly include requests equals, I think we're using, my notes tell me 2.3 in this case, but we can see from pip freeze as well. And what we now need to do here is actually explicitly import both requests and import the pandas as PD, as well as IO, but from inside the step, because now we know that this step is going to run isolated inside of its own component. So let's go and try and give it one more look to see if we're going to get just a bit further this time. So we see that the Python images are there. Yes.
Just to maybe to give to ask questions. If we create a step like this, it means also we can reproduce it in another use case, right? Or in another project that can benefit from the same.
Yes, essentially, exactly. The good thing is that also we're declaratively defining that, okay, this is the Python code that should actually run with this base image and those packages. So actually, it's quite clear if someone would like to convert to another system to say, okay, so that's where I need to start from, and the extra packets that I need, and even copy the code as it is to just run only this isolated step. So on the road of failures, we continue straight on, and we see again yet a different error this time. So first of all, we can see that KFP is doing some of the pulling things and complaining for pip running as root. That's an interesting one that we're going to also talk about in a second. But this time, the error that we're seeing is that, first of all, we're seeing a log downloading the model from the URL. This is, if you don't remember already, something we have in our print statement. So it got to this point, but let's see why it complained. It even successfully created the pandas dataset. So that means that it even got to the final print. So what is the problem? So if we take a slightly deeper look, let me see if it's slightly more explained on the executor runtime. Yes. So the error is that the return type that the pipelines got actually doesn't really meet what pipelines expected. And now this is where we're slightly starting to get introduced on how is data passing working between pipelines. Because here I just naively took the data frame object from pandas and tried to return it from my function. But pipelines, because everything is meant to be run as a container for different steps, cannot actually work this way and get the data set. So how can we actually then do it? The answer is that for this reason, Pipeline DSL has defined a list of parameters which are called input and output data types, in which we can have two kinds of types. One is called a parameter, and the other type is called artifact. And the main distinction between those is that one is meant for smaller kind of data, and the other one is meant for bigger amount of data. And from a technical reason why this is the case is on how the data is passed between the steps. And you can think it in your mind as for parameters, they're only passed as when I do Docker run, just arguments in my terminal. But when I want to have an actual artifact, this is now a file that has a ton of terabytes that I just give to my container. I'm not defining the contents of my file when I run the container. So in this case, we're going to define a dataset argument, but this is going to be a DSL output artifact, and it's actually going to be a dataset artifact. They have three definitions of dataset, metadata, model, and generic artifact that we can define from. We're going to see the differences they have between them. And what now we will need to do to expand upon and touch on KFP is Kubeflow pipelines can take care of, once we have our output artifact, we can access a path for the file of this artifact. And now what we need to do is actually go and write to this output the contents that we want to have. Because now a follow-up step can actually go and look at those outputs and directly run them. So now instead of getting the returning the data set, what we're going to do is actually save the data set. So we're going to have a conflict of names. So let me actually do df over here so we don't have a conflict with the output parameter. So we're going to go df to CSV so that we save it. And where should we save it? To our dataset output variable, which has a path property. I'm going to set indexing to false as well. And with this, we're now fully almost converted our step into a pipeline component, which is fully encapsulated and will run on a base Python container image, install the packages we need, have all the definitions inside. And the way that you can now return the output is we need to explicitly go to the variable that KFP understands as an output and go to that file and try to run our content. So if we try now to run this file, whoops. So if we now go and try to run this file again, we're going to pray to the demo gods, but maybe I've forgotten something, but we're seeing people installing things.
I have to say that it's not, it is rare that we end up having a live demo in a webinar, which is extremely impressive.
And success. So as we see, the download step succeeded. And first of all, the regular output from our executor is telling us these are our inputs in the function. And now we also see the outputs from the artifact. And as we defined, we see the dataset variable from our code, starting with no metadata. We'll talk about in a sec. And we can see the URI that it has, that is here a local file. And even at the end, we see that, yes, the dataset parameter is an artifact of dataset type, named dataset because that's the name of our variable, and it's stored here. And what's the impressive thing with running things locally is that we can actually inspect things that we have locally. So we have a local outputs directory that actually has now for the pipeline run that we had for this specific time. It also has the step that the function that we call, which is the data set, and inside of it there are two files. One is the data set, and then there is some metadata. So we could even now do some local, even inspect the contents of this one. And as we can expect, this is now the JSON file that we downloaded from our step. So to take a minute in retrospect, we actually just created our first Kubeflow pipeline component, fully encapsulated. We managed to run it locally, and at the end, we also got to visualize the output of this step locally from our laptop. So to speed things up, to ensure we are gonna see how we're gonna get to the Kubeflow. This is a very neat thing with running pipelines locally, because now all of the development environment for actually creating a pipeline can be fully replicated in our laptop, and pipelines actually follows a lot of the development approach that it would by running Docker. In which case, our dataset, for example, now is going to be a file that is stored somewhere. That now, for the next step that we're gonna have, KFP will take care of loading this file into our step and then magically using it. So, and what changes then in the context of Kubernetes is, okay, locally I have Docker and I just tell it to use different files. In terms of Kubernetes that we have Argo, the mechanism there is that, okay, how can I ensure that my file is going to be present on a different pod via Argo and transparently pulling the things from S3. So let's go to the second step of actually doing some pre-processing. So I'll try to be just a bit efficient.
And it's all right. We have time. I'm sure our audience is excited to see this demo.
Oh, nice to see. Perfect. So let's go the same example. We're gonna start with our second function now. Hope this is muscle memory by now, but we need to define our component. The base image. Actually, let me just copy and paste it directly from. So we're starting from the same base image, and let's take a look. In this case, we're only using data frame, which the previous function would get the data frame directly from the code. But here we've seen how KFP expects things slightly differently. So what we're actually going to do here is we're going to update this variable to be an input parameter to this file, because now we expect Kubeflow Pipelines to do its magic, and for this step to somehow automatically get the file for where it expects it. So have our base image, and what we need is, what am I typing? Oh, the data set. And now this previously it was an output. This time it's just going to be an output parameter. Of course, it's going to be for a data set type, so we're keeping this the same. And we're going to need to add another one for the output of the preprocessed model, since, again, this is something that we need to pass to another step, but let's take it step by step. So, as you expect, we'll need to start by importing pandas as PD. Why? Because this time, in order to use the DF, we will actually need to load again the file from a specific place. Where is this place? Of course, as you can expect, is pd dot. It's read CSV, isn't it? Yes, it's read CSV. Where is the file that we want to read from? It's dataset, the input parameter, dot path. And KFP is doing its magic and ensures that now my new container step is going to actually have available this file, so I can just use its path and read its contents. Again, in Docker, because it's going to just mount this file to the Docker container. In Kubernetes, because when we're going to deploy the pod, Argo transparently is going to pull the file and have it in a place that KFP now will go and tell to Python where to be able to access this file. Now we're just reading our file over here, and we've converted our data set. And the last part that we'll now need to do is to actually write to the outputs. So let's actually also have one more parameter. Let's call it preprocessed data set, which is going to be of type output, and dsl.dataset. And same as before. Whoops. What we're going to do is data frame to CSV, where, of course, into the preprocessed dataset.path, and that's it. So we will also now need to go, and since we defined our second step, go and create a second step, which is going to be the preprocess data. Let's call it just preprocess task to keep things simple. And now this is going to be the preprocess dataset function that we're going to call with, as we remember, positional arguments. And here's the first thing that we need to do. As we're looking into the definition, the first one is a dataset input parameter. So how do we tell the Python code that now our function should actually take the output from previous step, which is the download dataset? Now, the way we're going to do it is we're actually first going to use a named variable because this is important pipelines, as we saw. And what we're going to do here is go and actually reference the previous task that we have, go to its outputs, and actually now we're going to get the name of the variable that holds the dataset that we have. The name of the variable that we want as an output, which in this case was just dataset. Perfect. Where am I? I'm here. So we're going to go and tell to Kubeflow Pipelines that the dataset input variable of our preprocess dataset function is actually going to take the value of the previous task's outputs, and which output? The one that we have as dataset. Now, you're going to see my editor start complaining a bit because right here, we're actually now defining only one parameter of this function, which also have an output parameter. Now, this is a side problem because pipelines will know and autofill the rest, but a regular LSP servers are not that smart and will complain a bit, but you can ignore it for now. So let's try and go and run again our code and pray one more time to the demo gods that our pipeline now is gonna be able to fully process our next step for preprocessing the dataset. So as we can see, we're starting with the download dataset step that is actually again started for Python 3.12. pip is doing its magic to pull the packages that we defined, and it completed with the first task. And let's go to the second one, preprocess the dataset. Starting again with 3.12, it's pulling the Python packages. Please, pip, don't cry to us. Yep.
Gods seem liking yesterday, Kimonas.
Let's not jinx it. Let's not jinx it. So waiting is good. And we have another success. And what we can see right here is that, again, it's the usual flow. Our executor has as an input a dataset variable that is an artifact type, not a parameter, which means it's an actual file. And that's why we have in the URI a file. In Argo, this would be an S3 endpoint, and KFP would do all of the magic to then just pass this to the different step. As an output, we have our preprocessed data set, which is again an artifact. And in the end, it's also being written over here, which of course we can also go and look again into our local outputs. And we're gonna 50, I think it's 58, it should be 58. It looks bigger, so I would say yes. So yes, preprocessed data set. We also now see this task, and we see also the output, which is the preprocessed dataset variable. And indeed, if we take a look, we have fixed we have an underscore in the names and no spaces. So the preprocess step worked neatly as we expected it, and we have defined now also the code for the preprocess. And now to speed things up, at this point you're not going to learn a lot on going to training to converting the train model. So I'm actually going to copy the code from my little bit of cheat sheet on how this would look like, so we can go a bit and see how this now will look into pipelines.
The pipelines, you mean the Kubeflow pipeline UI, right?
Kubeflow pipeline UI, correct. So we can see the whole picture and get the overall idea of. So in this case, again, it's the same simple. This everything that we saw. Our train model function is going to take a data set that we want to use and has as an output the model. please pay close attention that now the type is model, the output artifact. And why this is important, we're going to see into just a second. Here I'm also installing both scikit-learn and pandas because that's the code that I'm using. The regular flow that we saw, we're going to read again our data set from the file that KFP automatically handles for how we see it. We're going to import again all of the imports that we wanted. The code here is the same, which we're only splitting the data set with, and then run our model with the hyperparameters. We'll need to define them in just a second. You'll see where. We're going to feed our code, see the score. But here's one extra thing that now we can do in this case. First of all, we'll also need to save the model because we'll need to save the model. So for this, I'm going to copy over and show you how this would look like. In this case, now at this point, I want you to remember that we've trained our classifier, and we can see it's also its accuracy. The way now that we store it is exactly the same as what we've seen. We have our output artifact that has a path, and we just need to write to this file. And what are we writing in this case? In this case, we're using pickle to actually take the whole Python object and put it into a file. In case of TensorFlow, for example, this would be the save model function of TensorFlow that would put the TensorFlow model into the file. And the last and interesting important part is that for a model artifact, we can actually have some metadata that we can assign to it. So in this case, I can go and assign the hyperparameters that we defined and put it as a metadata to this model. So from the hyperparameters and variable that I got as an input to the function, I can just go and give this as metadata. So I know that easily what hyperparameters I used. And in this case, I'm also going to add the score as well. So L1 ratio, whoops. And let's also add the score. Perfect. So let's try to also run this locally so that we can confirm that everything will work as expected. Now, while this runs, I'll do one last iteration. Oh, no. All right.
We were almost there. Almost no problem.
So actually going to copy. Andrea, would we have like 5 more minutes?
Yes, we do. We have around 8 to 10 minutes left maximum.
Right.
We will not take, just to give everyone context, in this case, we will not take live questions, but we can answer them in the chat as well.
Sorry, folks. We'll be there to chat. So what we're doing is actually now defining our train. We forgot to define our train task. Now, as part of the pipeline, we define our hyperparameters. But this could even be something that would give us input to the whole pipeline so we can try with different optimizations. The reason I'm putting it here is because I want you all to play around then with documentation, and you could even see how you can define for loops in the task, so you can try different combination of hyperparameters that can be trained in parallel. But for now, I'm just going to keep it simple and pass the hyperparameters to the function. And again, as input, we're going to use the preprocessed task that we just ran and take its preprocessed dataset output parameter and put it as an input. So our code previously succeeded, and let's try to rerun with the new model. And again, what this function is doing is run it in Python 3.12 with all the packets that we need. We read the file that we defined, and then we're training our model. And at the end, we're writing it to the output variable via pickle to the path of the output variable. And we're also assigning some metadata to the actual artifact that, as we saw, is actually a model artifact this time and can have also some metadata that now we can also see with Kubeflow pipelines. So we're pre-processing the data set, pulling into the all the dependencies. All right, things are working. And let's see the train model step. And once this succeeds, we're almost ready to go and see how now what the connection is going to be with Kubeflow pipelines. Pulling everything.
While it runs Kimonas, is there any limit on how many steps you can have in a Kubeflow pipeline?
As many as your heart wishes. No, there are no steps, and you can do all sorts of complicated things. And oh no, so there is a small issue right here. Oh yeah, okay. So a professor at my university said that copy pasting is a very bad thing. So in this case, it shouldn't do hyperparameter score because score is on the hyperparameters, but just score, which is the variable that has the score. So I'm gonna pray and I'm gonna have it one last run, but in parallel, let's start talking about how we can now go from running our pipeline locally that we've seen into actually converting it into a pipeline to the cluster. And how it looks is we have two approaches here. One is we can go to a notebook directly in Kubeflow, copy paste all of our code, and from that moment on, from our notebook, we're playing with the KFP CLI to then go and apply the pipelines directly, create the run and experiment. But I'd like to take a slightly more graphical view and actually show you how you can go with approach B to do things mostly from a UI. And the extra things we'll need to do here is actually convert this pipeline definition into a YAML that then we can use it to instantiate different runs from. So we're going to import KFP, and if my memory is correct, we'll have to do .compile, and we're going to take our MLOps pipeline and create now a YAML file from this pipeline. It's not a known attribute. Okay, let me check my notes. I'm pretty sure that would be the case. Yes, that should be the case. So we're going to ignore what we see over here. Train model is running. And just for the sake of time, because I want to ensure that it succeeded, I'll have it run again, just so that we can see the output of the MLOps pipeline. But for now, I had this file already generated, so we're just going to upload it, and by the end of while this executes, we're going to come back and confirm it locally that it got generated as well. So what we're going to do right now is the time has come for us to jump into the Kubeflow dashboard, actually, where we will go into the pipeline section. And this is where now we're going to upload our custom pipeline. We're going to create a new one. It's going to be private, which means everyone only the namespace should be able to access it. And we're going to do it by uploading it from a file.
Which is the YAML file that we just created, right?
Exactly.
And I have a question. If we want to edit it while it uploads, do we need to edit the YAML file, or can we edit it in any other different way?
So that's a very good question. In order to edit things, we would then need to go to the notebook and have all of the cells, the definitions, and rechange it, and with the SDK CLI from the notebook, apply it again and update the. Of course, we could do it here and run it locally and regenerate the YAML and upload it, but that's going to be slightly more painful now. And this is where from now, you expect users to, once they have defined most of the structure, then go and start now playing more on Kubeflow, because they will now work more on their notebooks, have their pipeline code there after they've played initially local and have something that works, and now keep on iterating from Kubeflow. So as we can see, the pipeline definition is here. Everything defined, the data set, our different steps, and their input and output artifacts, the input data set and the preprocessed data set output from the data preprocess, and for train that has an input parameter that we're manually putting, and a data set input and a model output. So out of this, just to show the whole picture, what we can now do, and that's going to close the tutorial from me, and hopefully I'm on time. So we're going to create our custom experiment, because different pipeline runs are grouped by experiments. And my wine tasting. So we're creating now the ends. We're going to go and read our private pipeline. We're using the pipeline to actually initialize a run. Remember, we create only pipeline definition, which is the YAML of what are the steps. And now we're actually going and create an actual step. So we have one input parameter, which is the dataset URL. So, this succeeded as well. So we can see also the envelopes pipeline YAML, but for the sake of time, all right. So let's take the dataset URL. We put it, and we're starting the run. And now we're actually going to see that in our Kubernetes clusters, all of the steps that we saw running locally, now we're going to be seeing different pods being created for each and every one of the steps that we just defined. And that's how magically now we went from running things locally. This error is going to go away in a second. Don't worry too much about this one. How we start running things locally from our laptop as container steps, all the way now to having the same code run as pods on Kubernetes. And with this, hopefully I'm right on time. So hope you enjoyed, folks. We'll try to also include some interesting links that you can use to run some of those, like creating your own pipelines, running things locally, and some of the data types, for example, so you can also try to replicate and run this exercise at home. So with this, I hope you enjoyed.
Thank you very much, Kimonas, and thanks for joining me. We are stretched on time, so I'll quickly go to our last slide on what are the benefits of using Kubeflow pipelines. I think you already summarized them very well, but it basically streamlines workflow automation. It improves collaboration, and also it accelerates project delivery by enabling different data scientists to reuse different components. It enhances performance, of course, as well as the resource optimization. So we don't all run the same steps over and over again. And last but not least, it gives you actually extensive support for popular machine learning frameworks that we did not talk yet. If you would like to try it out, the demo itself, don't shy away from downloading Charm or from installing actually Charm Kubeflow from charm-kubeflow.io. We're going to leave you the link, as well as share your feedback with us on how did you find this webinar? What are the topics you would like us to approach as well? Thank you, Kimonas. As usual, it's been fun to have you around, and I look forward for our next adventure.
Cheers.
Bye-bye.